those processes to reclaim memory periodically, and we are not using garbage collection at all for certain packet processing process.
That's right. Tell us about garbage collection again.
Hello everybody. Let me introduce myself. I'm Maxim Kharchenko. I'm a founder of Cloudozer, the company behind Erlang on Zen. We'll be talking about a project that we did and continue doing with Infoblox. The project is called LINCX. It's the next generation of link switch. So the initial scope of this project was to, first we needed to demonstrate that our platform, Link, we call it Link, which is not to be confused with Link. This is an absolutely different thing. But you could say that Link runs on Link. So what we needed to demonstrate is that Link is compatible enough to run serious software like a link switch. Link, it's an lossless environment, so definitely it cannot replicate the Erlang OTP completely, but it is compatible enough to run a link switch. From that time on, we also took on a task of making link switch run faster. First of all, we checked how the standard or the old code works on our platform, and the measures that we did, it showed that the processing delay, the time just between the moment then the packet enters the switch and until it goes out, it was about 200 microseconds. So we were specifically targeting decreasing this number. So what we did, we replaced a portion of link switch. We call this portion a fast pass. So this is the portion which really shovels packets at the high rate. And our efforts were not completely useless, so we were able to decrease the processing delay by 2 orders of magnitude. So it's now more like 1 or 2 microseconds. Yeah, but because I was going to get that thing on it was me, but I decided because because I'm using serial interface, like no operating system, so it got wires and it looks like like improvised explosives. So how we did achieve that? First of all, we used the standard pattern matching of Erlang. At a glance, the Erlang looks like an absolutely ideal thing for implementation of a software switch. All this binary pattern matching thing, nobody else can do that. Almost no other programming environment can do that. But the problem is so that the flow tables they change dynamically. We decided to use another standard and unique feature of Erlang, which is dynamic code loading. So what we do is that then the flow tables are updated. We compile it into Erlang code and then reload the flow tables dynamically, and it just runs really fast because of that. Also, another thing you should watch, and we were trying to achieve, is avoid garbage collection at all costs. We did just that. We used the non-standard option, which suppresses garbage collection for a given process, and we restart those processes periodically to reclaim memory. In terms of processing delay and in terms of packet rate and in terms of data rate, they were all confirmed using standard, industry standard techniques. And it showed that the LINCX can process about 450,000 packets per second. And for very...
On what kind of hardware?
Yeah, for these tests we were using an absolutely standard server, standard x86 server. So no special tweaks, for better network processing. Just a regular plain vanilla x86 server.
Rush Town, Def Jam, we in the house.
Also, for variable size packets, we easily saturate 1 gigabit Ethernet interfaces in a full duplex mode. So there is a 2 gigabit traffic going through the switch in both directions. These numbers, they constitute 2 orders of magnitude increase in terms of data rate than compared to the old code, and it means that link switch on LINCX is kind of join a different breed of software switches, where really we started to compete with the best and the fastest there on the market. To use multiple cores, you just need to spawn more instances of the virtual machine, and then you may assign, for instance, several ports to one instance and another couple of ports to another instance, and you may have linear performance increase then you add in more cores. These are not tested, and this is our future direction. This will require quite a bit of effort because of the coordination between these individual switches. But this will allow us to achieve even more performance-wise. So we eliminated operating system from inside the virtual machine, but we also want to eliminate the operating system when it comes to managing the hardware interfaces. We want to try to talk directly to hardware network interfaces. This may shave another microsecond from the processing delay, and we may really get something like a next generation of a software switch, which will compete not just with the software-based things, but also with the things with the hardware accelerators. But these are all probably another half a year ahead. Well, thank you very much.